to illustrate how to turn an ERD into a logical design, we'll illustrate how to do so for the ERD that we created in Module 3 for Exercise 2, the St. Pete flight exercise. And I've repeated I've copied the ERD here. So the first step we're going to do is we're going to take the entities in the ERD and we're going to turn those into tables in our logical design. So let's start, and we'll make sure that the unique identifiers which in the ERD are indicated by the asterisk in front of them, in front of the attribute, become the primary key. So let's start with pilot, emp, name, pilot name, pilot date of birth, and pilot hire date, and then we make emp name the primary key. Now we need to do this for the other entities as well, but I cheated and already created those. So we have flight with flight number, flight date, a composite primary key, passenger with passnum, airplane with serial number, and maintenance with procedure number, and we need to make procedure number the primary key. All right, so now before we turn to the relationships, we want to make sure that these tables are in first normal form. And well, in fact, in third normal form, we'll look at first normal form first. And we'll see that we have pilot name and pilot, passenger name and passenger, as well as passenger address. And those are likely to be non-atomic values. So we're going to make these atomic by pulling them apart. So we get pilot first name, pilot last name rather, pilot first name. And we'll leave the rest. And we're going to do the same for passengers. So passenger last name, passenger first name, and then we're going to do the same for passenger address. So we get passenger street number, passenger street name, passenger city, passenger state, and passenger zip, and then we can get rid of the address. Now, it is likely that the pilot date of birth, pilot hire date, and so on, and the date on the flight are non-atomic as well, because they will consist of a day, a month, and a year. But we'll leave those as is because we don't think it's going to lead to any problems. The next thing to look at is to see whether the tables are in second normal form, whether there are partial dependencies. And since there is only one entity with a composite primary key, namely flight, we need to check it. Now, it seems likely that the flight number will always have the same departure time and the same arrival time, independent of the date on which it is scheduled. So this one is likely to violate second normal form, because flight departure time and flight arrival time depend on flight number only. So what we're going to do is we're going to solve this by pulling this apart. So we'll have a flight which has the composite primary key flight date, flight number and flight date, but we'll create the object flight schedule that has the flight number as its as its primary key with flight departure time, flight arrival time, and then we need to make sure that we record the fact that flight number in a flight is a foreign key. So this is now in second normal form. The tables are now in second normal form. So now we need to test to see whether the tables are in third normal form. So are there any transitive dependencies between the attributes? And it's likely that there is a transitive dependency in airplane, because once we know the plane model, we can assume that we know the plane manufacturer and the plane capacity. In other words, plane manufacturer and plane capacity are functionally dependent on plane model. So this violates third normal form. So what we're going to do is pull this one apart as well. So we have plane and plane model. And plane model will have as its primary key plane model, and as attributes plane manufacturer and plane capacity, right? And we can remove these attributes now from plane. We make plane model the primary key in the new entity that we just introduced, and we record that it's a foreign key in the entity that it came from, namely airplane. So now we have the tables in third normal form. So we can now turn to the relationships, and we notice that the relationship between pilot and flight is one-to-many, and the way we code that up is by adding the primary key of the one part as a foreign key to the many part. So what we'll do now is we'll add emp num. This is not a, don't want to underline it. Let me get rid of the underlining here as well. But we want to record that it is a foreign key. Similarly, we have a one-to-many relationship between airplane and flight, and we can therefore add the primary key of airplane, which is serial number, to the flight as well. So let's do that. And let's record the fact that this is a foreign key. We now turn to the relationship between flight and passenger. And we notice that that is a many-to-many relationship. And in order to code up a many-to-many relationship, we need to introduce a intersection entity. The primary key of this intersection entity can either be the primary key, a composite primary key consisting of the primary keys of the entities that are standing in the many-to-many relationship, but it's preferred that you simply introduce a made-up primary key. So we'll do that. We'll call this entity a trip with trip number, and then we need flight num, flight date, which is the primary key of flight, and we need passenger num, the primary key of passenger, and then we need to add fare and reservation date as well. And then trip num will be the primary key, and flight num, flight date, and pass num will be foreign keys. And now we need to do the same thing to the relationship between airplane and maintenance procedure. So we'll call this a maintenance log. We give it a made-up primary name. Then we need the primary keys of the entities that are standing in this many-to-many relationship. And then we need to add the attributes on this intersection entity: date, location, and duration. And then we need to record that this is the primary key and that these are foreign keys. And now we have turned this ERD into a logical